The global conversation around artificial intelligence is currently dominated by a race for supremacy. It is a competition defined by the search for all-purpose intelligence and trillion-dollar investments in massive data centers. For 6.8 billion people living in the developing world, this existential debate over the risks of a super-intelligent mind feels like self-absorbed noise. Their reality is defined by a massive capability gap. While the West debates the future of white-collar work, the Global South is struggling to provide basic cognitive services in education, healthcare, and agriculture. Training enough doctors to read a medical scan or enough agronomists to support 1 million small farms takes generations of schooling. It is a slow, human-intensive process that many countries cannot scale fast enough to meet demand. AI offers a way to plug these holes in expert knowledge directly, functioning as a force multiplier for the specialists who aren't there yet. If building a university system takes 30 years, deploying a diagnostic tool takes months. By focusing on these specific adaptations, developing nations can scale human expertise at a speed that was physically impossible in any previous era. But there is a bottleneck. The entire AI stack, the chips, the servers, and the models themselves, is currently controlled by a tiny circle of providers. This chart shows the geographical reality of the industry. The firms providing compute power and underlying models are almost exclusively in the United States and China. This concentration creates a dependency trap. Developing nations become passive consumers of finished applications they do not control. Blindly adopting these foreign tools often backfires because AI models are sensitive to the context of their training data. They learn the specific medical norms, legal structures, and cultural nuances of the countries where they were built. We saw this when a Western AI for COVID-19 triage was tested in Vietnam. Because the patient demographics and clinical environments didn't match the training data, the system's performance failed to meet local needs. To solve actual development problems, software must be rebuilt or fine-tuned to reflect local conditions. This leads to the strategic middle path, adaptation. Instead of building trillion-parameter giants, local developers can take open-weight models and shrink them into specialized tools. This chart shows that while most governments are currently buying broad predictive analytics, the real opportunity lies in the smaller, more specialized categories below. We call this small AI. These are lightweight applications designed to run on a basic feature phone or even offline, serving areas where electricity and internet access are unreliable. In Ghana, the Rory system uses simple SMS messages to provide math tutoring. It costs just $5 per student and provides a full year of learning support, even on the weakest mobile networks. Similarly, an app called Nuru lets farmers scan a diseased leaf and receive an instant diagnosis offline without needing a connection to a distant server. These narrow, low-cost applications offer more immediate economic value than the multi-billion-dollar pursuit of sovereign AI. However, none of this works in a vacuum. AI is a general-purpose technology, which means its effectiveness depends on analog complements. Digital tools cannot scale without a physical foundation. Reliable power and broadband connectivity are the tracks that allow these services to reach the people who need them most. Then there is the human factor. An AI-powered math tutor is irrelevant if a student lacks basic literacy. Digital progress is tethered to the quality of a country's primary schools. By building these tracks and schooling their citizens, countries move from being mere users of foreign technology to being the architects of their own digital development. AI is spreading faster than any technology in history. Steam power took 80 years to reach lower-income countries. The internet took 20. ChatGPT reached those same regions in months. History shows the cost of being late. Countries that missed the first industrial revolution saw the global wealth gap widen into an impossible chasm that took 2 centuries to even begin to close. The choice now is between watching from the sidelines or using small AI to bridge those gaps today. The stakes are the integration of 6.8 billion people into the modern economy. For the first time, a technological revolution is moving fast enough to provide those workers with the tools they need to catch up.